Assalamu alaikum students. I hope you all are good. In today's lecture we will learn about functions and their types. Let A and B be any two sets and R be a binary relation from A to B. We have previously learned the concept of binary relation. So then R is called a function from A to B if first condition, domain of the relation is equals to set A and every element of A is associated with exactly one element of B under the relation. Or we can say relation contains no two pairs having the same first element. Function is basically a relation from A to B which satisfies these two conditions. The relation which satisfies these two conditions is called a function. We have learned to find out a binary relation, we first find the Cartesian product and then make subsets of them. These subsets are called the relations, and among those relations which satisfies these two conditions are called the functions. Let us take an example. Set A, A, B, C, D and set B, E, F, G, H and I. We have to make a function f from set A to B. We have learned that when sets are given to us, the first step is to find the Cartesian product. Second step, to find a relation. To find a relation, we just make the subsets of Cartesian product. If that relation satisfies the two conditions, it becomes a function. So start solving the example. Step number 1, find the Cartesian product A cross B. Start making the pairs. The pairs of A will be AE, AF, AG, AH and AI. Similarly, the pair of B will be and the pairs of C and the pairs of D. This is our Cartesian product. First step is done. Second step, find out relation. Relation is just a subset of Cartesian product. We may take any subset. Okay. Here we have considered AE, comma BG, comma CF, comma DI. We have considered these four ordered pairs. Now let us check whether this relation is a function or not. The first condition, make the set of domain. We have learned that the set of domain contains all the first element of ordered pair. So the set of domain will have A, B, C and D. Here we can see that the set of domain is equals to set A, this one. So our first condition is satisfied. Now check the second condition. Every element of A is associated with exactly one element of B. Or we can say that a relation contains no two pairs having the same first element. Here we can see we have A as a first element, here B, here we have C, here we have D. We do not have any pair which has same first element. So the second condition is also satisfied. So the relation which we have considered is actually a function from A to B. This is a diagram in which we shows ordered pairs. Take another example. We have a set A 1 2 3 and set 2 3 4 5. Now we have to make a function from set A to B. Again the steps are same. First step is to make Cartesian product. Second step, find out a relation by making a subset of Cartesian product. Step 3, check whether the two conditions are satisfied or not. So our step 1 will be find out the Cartesian product. Here is the Cartesian product. Step 2, make a relation. Here we have chosen these four ordered pairs. Now check whether it's a function or not. The first condition, set of domain should be equals to set A. Here we can see set of domain will have 1, 2, 3, okay, which is equals to our set A. It means first condition is satisfied. Now check the second condition. Second condition says there should be no two pairs which have same first element, but here we can see that we have two ordered pairs which have same first element, so our second condition is not satisfied, hence the relation which we have considered is not a function. Let us consider another function R2. Now you have to check it yourself whether it is a function or not. Then we have a function, then we have a relation R3. You have to check it yourself whether it is a function or not. Types of functions. We have three types of function. The first one is onto function, which is also called surjective function. Second one is one-to-one function, which is called injective function. And the third one is one-one and onto function, which is also called bijective function. The first one, onto function. According to the definition, a function f from A to B is called an onto function if range of the function is equals to the set B. If the function satisfies this condition, then it will become an onto function. Let us take an example. We have set A, B, C, D, set B, 1, 2, 3. And we have to find out an onto function from A to B. Now the steps we will follow will be, sets are given to us. The first step, find Cartesian product. Second step, find out a relation. Third step, check whether it is a function or not, if it satisfies the two conditions for the function. If it is a function, then we will check the fourth condition, that the range of the function is equals to B. If all these conditions satisfies, then it will be a function and onto function. Now start step number 1, make Cartesian product. We have learned how to make Cartesian product. This is the Cartesian product, A cross B. Now take a relation. Let us consider a relation, a subset of Cartesian product. This one. We have taken these four ordered pairs. Let us check whether it is a function or not. According to first condition, this domain of set of domain should be equals to set A. Let us check A, B, C, D. Set of domain will have A, B, C, D, which is equals to our set A. It means the first condition for function is satisfied. Second condition says no two pairs should have same first element. Here we can see all the ordered pairs have different first element. It means this is a function. Now we have checked that this relation is actually a function. Next we will check this condition, that whether the set of range is equals to set B or not. Here we can see that the set of range which will be equals to 1, 2 and 3 is equals to the set B. So the condition for being an onto function is satisfied here. So the function that we have considered is actually an onto function. It's an onto function. Next we have one-to-one function or injective function. A function f from a to b is said to be one-to-one function if distinct elements of set A are associated with distinct elements of set B. If this condition is satisfied, then the function will be an one-to-one function. Let us take an example. We have set A and set B are given to us, and we have to find an one-to-one function from A to B. The steps are again same. Sets are given to us. First step is to find Cartesian product. Second step is to make a relation. Third step, check whether it is a function or not. If it satisfies the conditions for being a function, then it will be a function. Fourth step is to check whether the condition for being one-to-one function is satisfied or not. The condition for being one-to-one function is distinct elements of set A are associated with distinct elements of set B. Now our first step, Cartesian product. We have learned how to make Cartesian product. Second step, take a relation. The relation which we have chosen here is this. It contains x, 1, y, 2, z, 3 and w, y. Now we have to check whether it is a function or not. Make the set of domain. Set of domain will have x, y, z and w, which is equals to our set A. It means first condition is satisfied. Second condition, there should be no two pairs having same first element. Here we can see that all the ordered pairs have different first element. It means both the conditions for a function are satisfied here. Now we will check whether it follows this condition or not. Now we can see the function which we have considered have different second elements. It means the second element of all the ordered pairs are different. So we can say that any element of B is not associated with two or more elements of A. So the function which we have considered is actually a one-to-one function. In other words, we can say that the elements of B, the second elements, are not repeated. So the set is the function which we have considered is an one-to-one function. One and onto function, which is also called bijective function. It is a combination of one and onto function. If a function satisfies both the conditions for one and onto function, then it will be a bijective function. Let us consider an example. Set A which has x, y, z, w and set B which has 1, 2, 3 and 5. We have to find a one and onto function from A to B. Again the steps are same. Sets are given to us. Step number 1, find Cartesian product. Step number 2, find a relation. Step number 3, check whether it is a function or not. Step number 4, check whether it satisfies the conditions for one and onto function. It means the range of the function is equals to set B and distinct element of set A are associated with distinct element of set B. Now step number 1, Cartesian product. We have learned how to make Cartesian product. In the same way we will find out the Cartesian product A cross B. Step number 2, take a relation. You may take any relation of your choice. Okay, Now check whether it is a function or not. Here we can see that the set of domain will have x, y, z, w, which is equals to our set A. It means first condition for function is satisfied. Now second condition, first element should not be repeated. Here we can see all the order pairs which we have chosen have different first elements. So both the conditions for being function are satisfied here. It means this relation is a function. Now we will check whether it is an onto and one-one function or not. Let us make this set of range. The set of range will have 1, 2, 3 and 5, which is equals to our set B. It means the first condition is satisfied. And every element of B is associated with exactly one element of A. It means the second element are not repeated. So both the conditions are satisfied here. It means this function is an onto and one-one function. Here we have the summary of the lesson. Relation is actually a subset of Cartesian product. Next we have learned domain. Domain is the set of first element of a relation. Range is the set of second elements of a relation. Then we have learned function. For being a function, a relation must satisfy these two conditions. The first one, set of domain should be equals to set A, and relation contains no two pairs which have the same first element. Then we have learned onto function. For being an onto function, set of range should be equals to set B. For being a one-to-one function, distinct element of set A are associated with distinct element of set B. Next, one-one and onto function, it should satisfy both the condition for onto and one-one function. Now we are moving to the relative questions from exercise 1.3.